Welcome to the deep dive. Our mission today is, well, to really give you the essential takeaways from the source material on something pretty exciting. We're looking at the intersection of AI and specifically design to code workflows. It's moving fast. We've had AI helping us write code for a while now, like the copilots in our IDEs. But the sources are really digging into this next frontier, teaching AI to actually read designs. We're talking complex Figma files and turning them straight into software.
Yeah, exactly. And what's really interesting here is that it's not just theory anymore. The industry is kind of splitting already. We're seeing these two, well, competing ideas pop up right now. One's all about raw speed, using the terminal. And the other is more focused on, let's say, workflow integration and how teams actually collaborate. So we really need to frame this conversation around a key trade-off, something that you listening are probably already thinking about or will be soon. It's speed versus, well, nuance, right? This terminal approach, the one built around the Model Context Protocol, it promises incredibly fast initial code generation. But does that speed just hit a wall? Especially when you run into the messy reality of team workflows and keeping a design system consistent. That's kind of the core question for today.
Okay, yeah, let's definitely dig into that first approach then, because it does show off the raw power of these AI agents pretty clearly. It relies on two main things, right? Claude Code and this Model Context Protocol, MCP. So Claude Code, that's Anthropic's tool, the one that lives in the terminal.
Yeah, that's the one. It's an agentic coder, meaning it's designed to do more than just suggest code snippets. It can, navigate a whole code base, build out features just from a description, even debug things. It handles a lot of the tedious stuff.
Right. But an agent like that, it usually just works with text. How does it see the Figma designs?
Well, that's exactly where the Model Context Protocol, the MCP, fits
Yeah.
in. Think of MCP as like an open standard, almost a universal adapter. It lets AI, like Claude, connect different kinds of data, stuff that isn't just text, like design tools.
Okay, so MCP is the bridge.
Yeah.
And specifically for Figma, there's this Figma MCP Server component.
Exactly. This server basically acts as the translator. It takes all that rich data from Figma, the files, components, your design tokens, everything, and makes it understandable to any AI tool that speaks MCP. Yeah. And the immediate result, you can literally reference a live Figma design in your prompt. You tell Claude, build this frame, and it sees the design and generates matching code.
And the sources mentioned the setup is surprisingly simple, not some huge integration project.
Yeah, that was actually quite striking. It really lowers the barrier to entry.
You just need the Figma desktop app, flip a switch in the preferences for the dev mode MCP server.
Right, it runs locally. You get a local address, HTTP at 1T7 and 1.0.1384 CF45, I think it was.
Then just one command in your terminal using Claude MCP add, and bam, you're connected.
Yep. That's it. A couple of minutes, and suddenly your text-based AI agent can see your designs.
And then it can work in a couple of ways. Select something in Figma and prompt, or just paste a Figma link.
Correct. Either select a frame, tell Claude make a React component from this, or copy the link to a specific part of the design and paste it right into your terminal prompt. For generating that first version of a single component, it is incredibly fast. No denying that.
Okay, that speed is definitely appealing. But you mentioned hitting a ceiling. This sounds like where the command line approach starts to show some cracks.
Exactly. That's where we hit what the sources call the command line ceiling, because that initial speed is great for generating something new. But software development isn't just about generating once, right? It's iteration, refinement, updates, working with a team. And that's where this AI-first, terminal-first workflow really starts to struggle.
Wait, but if Claude Code is so smart, you said it can navigate whole code bases. Why can't it just look at the existing component code and figure out how to make a small visual tweak from the updated Figma file? Is it like a context window issue?
It seems to be deeper than just context window. It's really the first big limitation the sources highlight, the inability to update existing code effectively. Claude Code is fantastic at generating from zero. But let's say a designer nudges the padding by 4 pixels or changes a color token in Figma. The AI, well, it struggles to make just that tiny surgical update to the existing code. It doesn't seem to have that deep understanding of your component's structure, its state logic, maybe API calls you've added.
Okay, so it wants to just regenerate the whole thing.
Often, yes. Which means you either regenerate and potentially break all the custom logic you or your team painstakingly added, or you're stuck doing manual edits anyway, trying to reconcile the AI's output with your existing code. Basically choosing between breaking things or doing manual cleanup, creating technical debt either way.
That makes sense. You build components so you can reuse and evolve them, not rewrite them constantly. Okay, what's limitation number 2?
The second big one is handling complex multi-frame flows. Think about a typical onboarding sequence with 3 screens or an image carousel. In Figma, that might be spread across several frames.
Right. Pretty common stuff.
Well, with this terminal workflow, the sources say it gets really tedious. You can't just point Claude at all 3 frames and say, make a carousel. You have to convert each Figma frame into code individually. Then you need another series of prompts, trying to coax the AI into stitching those separate outputs together. You're trying to get it to add the navigation logic, the transitions. It takes a lot more time, a lot more back and forth.
It probably burns through a lot of tokens too, I imagine.
Exactly. That cost can add up fast if one simple carousel needs like 4 or 5 separate complex prompts plus manual assembly. The efficiency gain starts to disappear.
Okay, so updates are hard, complex flows are clunky. What else?
Limitation 3, the lack of a visual refinement loop. Once Claude spits out the code and it lands in your editor or repo, that direct visual connection is broken.
So you're back to the classic edit, save, switch to the browser, refresh cycle.
Pretty much. If you want to tweak how a hover state looks, or adjust padding slightly, or check responsiveness, you're editing the code directly. You could try prompting the AI again, like make the padding 8px instead of 12px. But the sources are pretty clear. This is often inefficient. It costs tokens, and the AI might still not get it quite right. So developers often just find it faster to override it and make the CSS change manually. The visual iteration loop is gone.
So fast initial generation, but then it creates potential tech debt, struggles with real-world flows, and forces you back to manual coding for tweaks, which leads naturally to the fourth limitation, which sounds more organizational, the developer bottleneck.
This is maybe the biggest one for team dynamics.
Right. Let's picture that scenario. It's Tuesday morning. A product manager has an idea for a quick A/B test. Just change a headline, tweak a button color.
Or marketing spots a typo on a landing page component that needs fixing now.
Or the designer realizes after looking at the build that the spacing is slightly off on mobile compared to the Figma spec.
Because this whole MCP plus Claude Code workflow, as described, lives entirely in the developer's terminal. Every single one of those small requests has to go through a developer.
So the developer becomes the gatekeeper for even tiny visual or text changes.
Exactly. The AI might make the developer a bit faster at generating the initial code block, but it hasn't actually removed that bottleneck in the overall team workflow. The developer is still the only one who can touch the code generated from the design.
Okay, that paints a clear picture of the limitations. This sets things up nicely for the second approach in the sources fusion. It sounds like it starts from a different premise entirely.
It really does. Fusion seems to ask, what if the problem isn't the AI, but trying to cram this inherently visual collaborative process into a purely text-based single-player tool like the command line?
So how does Fusion tackle these limitations differently? Let's start with that surgical update problem, the tech debt generator.
Well, this is where Fusion claims a fundamental difference. It's designed to understand not just the design, but also the front-end code structure and your design system. So when a design changes in Figma and you sync it, Fusion doesn't just regenerate everything. It analyzes the changes and applies only the necessary visual updates, the padding change, the new color token. Crucially, it aims to preserve all the existing logic, the state management, the API integrations you've already built. It's about continuity, not just generation.
Okay, that directly addresses the tech debt issue. What about those complex multi-frame flows like the onboarding sequence or the carousel?
Fusion is designed to handle that automatically. Instead of needing multiple prompts and manual stitching, it reportedly recognizes those common patterns. If it sees 3 frames laid out like a carousel in Figma, it understands the intent. And it generates a single complete component with the navigation, the transitions, even responsive behavior built in, all in one go. That avoids all the tedious prompting and manual assembly.
That sounds significantly faster for anything beyond a simple button. Now, what about that visual refinement loop? You said with MCP, you're back to code editing.
This is probably the most striking difference, and it connects developers and designers. In Fusion, the sources say you're not just looking at code snippets. You are working visually, but you're directly editing production-ready code React, Vue, Angular, whatever your stack is.
So wait, I can adjust padding with a slider, and it changes the actual CSS in the component.
That's the idea. You use visual controls, maybe drag the edge of the canvas to see how it responds at different breakpoints, tweak hover effects visually, and those changes are happening to the real component code instantly. It completely bypasses that prompt again or edit manually dilemma. You refine it visually before it even gets committed.
Okay, visual editing of real code. That capability seems key to the final piece, tackling the developer bottleneck. How does Fusion enable other roles?
Right. If the command line creates the bottleneck, this visual approach aims to remove it by allowing non-developers to safely contribute to production code.
So let's walk through those roles again. How does a designer's job change here?
Designers can go beyond just handing off static Figma files. They can import their designs into Fusion themselves. And then they can actually refine the interactions, check the responsiveness, make sure the generated component feels right, not just looks right in the static image. They effectively own the final interaction layer, ensuring the code matches the vision.
Okay, makes sense. What about product managers?
PMs can potentially move much faster on iteration. That idea for an A/B test. They could potentially create the variant themselves using approved, live components from the design system within Fusion. They could build a working prototype for a new flow, get a shareable preview link instantly, and validate ideas with stakeholders using real components before ever consuming engineering cycles. Faster feedback loops.
And marketing teams, landing pages are always a big one.
Exactly. For things like landing pages, campaigns, content updates, marketing could potentially use pre-approved components from the design system in Fusion. They could build or update pages visually, change text, swap images, and ship them without waiting in the developer queue, but still adhering to the established code standards because they're using governed components.
Now, the big question for anyone running an engineering team, how do you make sure this is safe? You don't want just anyone pushing code to production, right?
Absolutely critical point. The sources emphasize the safety rails built around this. First, all changes made in Fusion happen on a dedicated Git branch, automatically. Nothing goes straight to main. It generates preview URLs for every change so the team can review it just like any other code change.
Okay, Git integration is key. What about permissions? Can you lock down sensitive components?
Yes, it supports granular permissions, so you can designate core application components as developer only while allowing marketing, say, to edit only the text content or image sources within specific landing page components. You control who can change what.
That makes sense. Control the scope of change.
And it goes even further. The sources mention the AI itself can participate in the code review process. It can apparently respond to comments left on a pull request, fixing build errors automatically, or iterating on the code based on team feedback right there in the PR. It acts like an integrated part of the development workflow.
Wow, okay. That really paints the contrast clearly. You have the first wave Claude Code plus MCP, which is powerful for that initial code burst, but kind of hits a wall with updates, complexity, and team scaling because it's locked in the terminal.
Right, the terminal bottleneck.
And then you have this next generation approach, Fusion, which maybe sacrifices a tiny bit of that initial raw generation speed, but prioritizes everything that comes after. Surgical updates, handling complexity smoothly, visual refinement, and ultimately democratizing the process across the team.
Exactly. It shifts the focus from just generating code to managing the entire lifecycle of the component within a team context.
Yeah.
And if you zoom out, connect this to the broader industry view mentioned in the sources, this convergence of AI and design tools is just getting started, isn't it? The prediction was pretty bold, that soon writing HTML and CSS manually, which is still standard practice everywhere today, might look as well primitive as using tables for layout does now. A necessary step, but not the future.
That really does frame the future for us, doesn't it? It seems the question isn't if AI is going to completely change the design to code world anymore. The real question, the one you should be asking in your own organization, is, are you going to adopt tools that keep this incredible new power stuck behind the developer's terminal? Or are you going to look for platforms that actually manage to spread that capability safely and effectively across your entire product team?